This meeting is being recorded.
Okay. Greetings, everyone, and today we are from Group 6, and today we will be doing Lab 2 demo, and I'll be in charge of question 2, 6, and 4, and 6. Okay, so let's remove the comment first, and I will proceed with the debugging of question 2. So start debugging. So let's observe the data segment first. So as well, so the R val is basically undefined, and then S val is 1AH in hexadecimal, and Y val is 1H in hexadecimal, and Z val is 28H is in hexadecimal. So let's check the debugging. So move EAS with S val. So basically it just simple. You just move 1AH into EAS. So this value will be changed to 0.00001A. Okay. So next line we negates NEG basically means negates the ES content. So we make it as a two complement form. So this will be the this will be a two complement form for the ES. So it becomes FFFFFE6. Okay, so let's check. Okay, so let's remove EBS. Move the Y val value into EBS. So EBS will become 1000001E. So let's check 0001E. And then next line we sub EBS, basically subtract the EBS value with Z val. So the Z val is 40, right? And the EBS right now is 1E, which is 30. So 30 minus 40 is nearly 10 in decimal. So basically it will be F6 in hexadecimal. So we see the EBS value become that. So F10. Okay, so next line we add ES with EBS, and ES value is FE6, right? So it's basically negative 26, and then the EBS value right now is negative 10. So plus together we will get negative 26 in decimal, or we can say it's a FFFFFDC in hexadecimal. So ES value will become FFFFFDC. So let's F10. Yeah, change to FFFFDC. And then INCES, which is the next line. It basically increment the ES content by 1. So it becomes negative 35 in decimal, and or we can say it's a FFFFFDD in the hexadecimal form. So this ES will change. So let's check. Okay, change to FFFFFDD. And then lastly, we move R val with EAS. Basically, move the ES value into the R val and store it in the memory. So the R val, you see the R val here, it will become 0s FFFFFFDD. So let's check. Okay, yeah, it become FFFFFFDD. And that's all for the question 2. F10. Okay, then we make it a comment. Then we proceed to question 4. Question 4. Remove comment. Then we set the breakpoint. Set the breakpoint. Debugging here. Start debugging. Okay. So question 4 is basically about multiplication and division and the idea of concatenation. So let's start with data segment first as well. So var 1 is 40, which is 28H in hexadecimal. var 2 is 10 in, or we can say it's 0AH in hexadecimal. And var 4 is the undefined value. So let's start debugging. Move AS with var 1. So var 1 will become, so AS will become var 1 value, which is the DH. So you can see the 4 behind 4 bit So it become 0028 F10. It comes 00028. And then we move BS with 5. So we can see the BS value become 0005. Let's see. Okay. And then in mul BS basically means multiply the content of AS with the BS. So its result will be stored in the AES DSAS form. Basically, it's a concatenation. So 40 times 5 is 200, right? So it's a C8H in hexadecimal. So we can see the AS and DS value change. So the last 4 bit of AS and DS will change. So it become 0000 for DS, right? Because it doesn't exceed the 4 digit. And then it become 00C8 for EAS. I mean AS, okay? So let's check. You can see 0000 So that's the result of the multiplications. And then next line, we move BS with var2. And then we can see the BS become 0AH. I've done. Yeah, 0A, see? And then next line, we subtract BS with 3. So it becomes 7. Let's check. 0007. Correct. So next line, we divide BS. Basically, we divide the content of the AS by BS. I mean, so it will become 200, right? Over 7. Oh, let me repeat. So it become DS concatenate with AS divided by BS. So it become 200 divided by 7. So the result will be 28 for quotient and 4 for the remainder in a decimal, right? So to convert it to hexadecimal, it will become 1C in hexadecimal for the quotient and 4H for the remainder. And then let's check. So the result will be stored in AS and DS. And AS will be stored as a quotient, DS will be stored as a remainder. After 0001C for the quotient, 0004 for the remainder. Okay, lastly, we move var4, move the result of AS into var4. So the result will be stored in the var4. So after the var4 will become the content of AS. So 001C. So let's check the var4 here. var4 and 001C. Okay, so I think that's all from the question 4. After then we comment it again. After okay. And then let's proceed to question 6. Okay, we comment this and then so again we adjust the breakpoint. Okay, then we start debugging. Okay. So the first line is immediate registering, which is move DS to 0, DS 0. This one will become F10, become 0. Okay. So move AS with 803. This one become 0803. Okay. And move BL, these 2 digit. So become 008, I mean 110, 110, okay, 10. And then divide BL. So BL is a byte, right? It's a 8-bit. So actually this comment is I think some mistakes. So actually is divide AS by BL. Divide AS by BL because BL is 8 byte, right? 8-bit. So it will divide the content of AS. The content of AS, which is the a word, right, is a 2 byte. will be divided by DL. So actually the result will be stored at AH and AL of the ES, right? So the quotient will be AL and the remainder will be AH. So we can see 803H divided by 10H will become 80 for the quotient, right? 80H for the quotient and 03 for the remainder. So because the remainder and quotient is stored in AH and AL form, so the AH will become remainder and AL will become quotient. So the AX will become 0380. So you can see this one will change. F10 0380. And then next we check the dumb range, which is the ESE, the common prompt F10. So you can see 0380 change to 0380, which 80 is the quotient and 03 is the remainder. So that's all for question 6. Okay, and I think that's all for our demo. And thank you very much.